In the second part of section 4.2, we're going to be looking at increasing and decreasing intervals and the first derivative test. A function is said to be increasing if the graph is going uphill. And for the graph to go uphill, notice that all the tangent lines have to be positive. So if the derivative is positive, then we know that our function is increasing. Similarly, a function is said to be decreasing if it's going downhill. And if we look at all the slopes of the tangent lines, they're going to be negative. So if the derivative is negative, then our function is decreasing. Reminder from earlier in this chapter that critical numbers are where the derivative is zero or the derivative doesn't exist, and that relative max and mins, relative max and mins happen just at critical numbers. So the first derivative test says that if c is a critical number and the derivative changes from negative to positive at c, so that means it's decreasing and then increasing, then that value of c must be a relative minimum. And if the derivative changes from positive to negative, that means it's going uphill and then downhill, that must be a relative maximum. So let's take a look at a few examples here that will help us understand these. So we're asked to find the open intervals for which the following functions are increasing and decreasing, and we also want to find the relative extrema. So as soon as you see increase, decrease, relative extrema, we have to deal with the first derivative. So the derivative of this is going to be x squared plus 2x subtract 3. And then we have to find the critical numbers. So I have to set the derivative to 0. So x squared plus 2x minus 3 equals 0. So this is going to factor into x plus 3 and x minus 1. So that means we get two critical numbers. Okay, because if I'm multiplying two things and getting 0, either the first term is 0, so x is either going to be negative 3, or x is going to be positive 1. So now we're going to do the first derivative number line test. So this is going to be f prime, and you're going to put your critical numbers on the number line and put a 0 above, because those values make the derivative 0. Now we're going to take some test points, like negative 4, a number in between these two, which is 0 and 2, and we're going to test them in the derivative to see whether it's positive or negative. If I put a negative 4, this term will be negative, this term will be negative, and the product of two negatives is positive. If I put a 0, this term will be positive, this term will be negative, it'll be negative, and a 2 makes them both positive. So therefore, I know that my function is increasing wherever my derivative is positive, so negative infinity to negative 3, union with 1 to infinity. And I know my function is decreasing wherever my derivative is negative, and that's from negative 3 to 1. Now, does my derivative change signs anywhere? Yes, it changed signs at negative 3. It's going from uphill to downhill at negative 3, so that means negative 3 is a relative max. So I have a relative max at f of negative 3, which means I plug negative 3 into the original function, so it's going to be 1/3 negative 3 cubed plus negative 3 squared minus 3 times negative 3 plus 1. So this is negative 27 divided by 3 is going to be negative 9. That's going to be plus 9. This is going to be plus 9 plus 1. And if we work that out, it works out to be 10. So f of negative 3 is 10. So that's going to be my relative maximum. And my derivative also changes from positive to negative at 1. Or sorry, from negative to positive at 1. So I get a relative min at f of 1, which means I plug a 1 into my function. So it's going to be 1/3 times 1 cubed plus 1 squared minus 3 times 1 plus 1. This is going to be 1/3 plus 1 minus 3 plus 1. So this is really 2 1/3 minus 3. Work that out, it's going to be negative 2/3. So there's going to be my relative min. So again, to find relative extrema in intervals of increase and decrease, we use what's called the first derivative test. So we have a quotient rule we have to use to find the derivative. So first of all, note that x cannot be 2. Okay, so if I take the derivative, I get x minus 2 denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. So if I clean up the numerator, I get 2x squared minus 4x minus an x squared over x minus 2 squared. So I end up getting x squared minus 4x over x minus 2 squared. So there's my derivative. And now I have to find my critical points. So to figure out what makes the derivative 0, because I have a a rational, I just set the numerator equal to 0 to figure that out. So again, I can factor an x out. So either x is 0 or x is 4. And my derivative is undefined, whatever makes the denominator 0. So x minus 2 squared equals 0 whenever the term inside the brackets is 0. So that's when x is 2. Now I know 2 is undefined, so it can't be a max or min, but I'm still going to include that on my first derivative test because I still might get an increase-decrease change there. So I have 0, which is a 0. I have 2, which is an undefined, and I have 4, which is a 0. Again, I'm going to test -1, 1, 3, and 5, and I am testing in the first derivative. And if I look at the factored form, it's going to be x times x minus 4 over x minus 2 squared. And no matter what I plug in the bottom is always positive because it's squared. So it's really the numerator that's determining. So if I substitute a -1 in here, this will be negative, this will be negative, and the product of two negatives is positive. If I put a 1 in, positive, negative, it's going to be negative. If I put a 3 in, positive, negative, it's going to be negative, and a 4 is going to make them both positive. Now, when we write our intervals of increase, my function is increasing from -infinity up to 0 and union with 4 to infinity. My function is decreasing, and we have to be careful because my original function is undefined here. Now, my derivative is undefined, but so too is my original function. So you have to write it as two intervals. You could say 0 to 4, but not at x equals 2 because my function isn't defined. This would be acceptable as well, but that's how you would write an interval notation by excluding the 2. So right now I have a relative max because my derivative changes from positive to negative at 0. So I get a relative max at f of 0. If I plug 0 into the original equation, I'm going to get 0 over -2, which is going to be 0. And I get a relative min. And if I look at my number line test, my derivative changes from negative to positive at 4. So I get a relative min at f of 4. And again, plugging into the original, it's going to be 4 squared all over 4 minus 2, which works out to be 8. Okay, here's a multiple choice question from the 2003 AP exam, and it says, let f be a function with the derivative given as the following. Where is the function decreasing? So they already gave us the derivative. So my derivative in this case was x squared minus 2 over x. If we were to get a common denominator and combine these, this would be really x cubed minus 2 over x, which is the same thing. Now, to figure out the critical numbers, I have to set the derivative to 0. So I'm going to equate the numerator to 0. And if I cube root both sides, it would be the cube root of 2. And the derivative is undefined whenever the denominator is 0, which is going to be 0. So now I would place 0 and cube root 2 on my number line. This is an undefined. This is a 0. Let's use 1, 2, and -1. Plugging into the derivative, -1 cubed minus 2 is negative, divided by -1, that is going to be positive. Plugging a 1 in, it's going to get negative on top, positive on the bottom, it's going to be negative, and a 2 is going to be positive, positive. So we want to know where the function is decreasing, and that's going to be where the derivative is negative. So that would be 0 to the cube root of 2. I usually just use round brackets on these, but they use a round and a square at one end. Again, they'll never trick you and have a round and a square or two rounds over the same interval. So you can see that this answer is just going to be D. Okay, this is another good example, but now they're giving us the function, whoops, and in our function, we are told that the function is equal to x squared minus 3 times e to the negative x. It's kind of hard to read on the screen. So we want to figure out where the function is increasing. So the first thing I need to do is take the derivative using the product rule. So it's the first function. The derivative of the second is itself times the derivative of the exponent, which is -1, plus the second function times the derivative of the first. Now if I factor out negative e to the negative x, I'm going to be left with x squared minus 3. This will change to minus times 2x will be minus 2x. I'm left with negative e to negative x. This will be x squared minus 2x minus 3, which factors into x minus 3 and x plus 1. So now when I do my number line test, e to anything is never 0, so there's no zeros from there. This 0 would be 3. This 0 would be -1. And again, I'm testing -2, 0, and 4. Now you have to be careful. This guy here, no matter what I plug into x, I have a negative out front. This guy is always going to be negative. So -2 minus 3 is negative. -2 plus 1 is negative times this negative. It's going to be negative in this region. 0 is negative, positive, negative, which is going to be positive. 4 is positive, positive, but times this negative is going to make it negative. So it is increasing from -1 to 3. In an interval notation, it would be that answer right there. Okay, in our last example, we're looking at an AP exam question, and it says the first derivative of a function is given by f prime is cos squared x divided by x minus 1/5. And how many critical numbers does it have in the interval 0 to 10? Now, critical numbers, remember, is where the derivative equals 0 or where the derivative is undefined. And because they're giving me the derivative already, what I need to do is I need to graph this on the graphing calculator. So I'm going to delete all these functions. Okay, so I'm just going to delete this here quickly again and show you how I got this. Whoops, menu, actions, delete all. Okay, I'm just going to make sure that my calculator is set up in radians because it was set up in degrees. Okay, so now we're going to graph the function. So I'm going to go tab to get to my graph feature, and it was cos x. So opening my bracket, trig cos x, and this whole thing was squared. Then it was divided by x, and then I'm subtracting from that 1/5, which is really 0.2. So if I enter that, I end up getting a graph that looks something like this. Not sure why it's still in degrees. I got to switch this to radians again. Okay, we should have it set up. Now, there we go. There's our graph in radians. Okay, so now the question is how many times, how many critical values does it have? So how many times does the graph cross the x-axis from 0 to 10? Well, we can clearly see it crosses 3 times. So therefore, the solution to this one would be the answer of 3, which is B. All right, that concludes section 4.2 on increasing, decreasing relative max and min. So there's some problems for you to try from the Calc 30 textbook, so give those a try. If you have any questions, check the answers on the website.